Okay, so here's our third step in this little tutorial here with this same problem. I'm going to go ahead and figure out, I found in the second one here what our total resistance is. In our first video went through and we just kind of redrew our diagram. Alright, so if our voltage source here is 5 volts, our total voltage, our resistance is 3.23K, we should be able to find our total total current here. And I'll go ahead and do that just real quickly here. So current is going to be equal to here it's going to be voltage over resistance. Okay, so it's going to be so that's going to be 5 volts divided by 3.23, that's K. Don't forget your metric unit there. Alright, so if we take 5 divided by 3.23, we come up with 1.54. Okay, but because we're going to be times one over 1,000. So unit here is actually, well, there's our raw number. We move our decimal place over, we end up with 1.555 milliamps. Okay, so we're able to figure out our current now, and that's our total current in the circuit. Alright, we can use some other laws. So we use Ohm's law there. Let's use Kirchhoff's. We'll just see what we can come up with here before we solve anything. Kirchhoff's current law. Okay, if we apply this to the circuit we have, alright, current is always constant anytime we have things in parallel. Okay, so our current, take a look up here, our current at 5, resistor 5, and our current as we measured as resistor 8, which are in parallel, well, they're not going to change, are they? Okay, so we can say that the current at 5 is going to be equal at the current at resistor 8. Alright, and we can also say the same thing if we look over at resistors 1 and 2. If we measure current here and here, we're going to find that it's also going to be equal. Okay, so I'm going to say current at 1 is going to be equal to current at 2. Clean this up just a little bit. Like that. We'll come back to that. Okay. Let's move down here. And what other relationships do we know? Well, we can use Kirchhoff's voltage law. Go ahead and say that. It says that current is constant in parallel circuits. Okay, so as we start to look at this, we're going to find that voltage through resistor 3 and resistor 4 are going to be equal. I'm going to try and Just do a copy and paste here. Yeah, it's not going to let me do that. We'll also find that the voltage over here at 6 and 7 are going to be equal too. Okay. Let me do that either. Okay, and we could probably observe some other relationships here too. Like for instance, these two resistors are equal, and they're in parallel, so that we can say that the current's going to be equal there. The current at I6 and I7 are going to be equal. Let's look at that. So since R6 is parallel with R7 and R6 equals R7, we're going to find that the resistance, even though these are in parallel, the resistance through resistor 6 and the resistance through resistor 7 is going to be equal. What else can we observe here? Okay, these two are in parallel. Okay, and so we can say that the resistance here and resistance here is going to be equal. So resistance through 1 is in series with resistance through 2, and resistor 1 value equals resistor 2 value. Therefore, voltage is going to be the same. Okay?